Hello everyone, welcome back all of you. In this session we are going to have a discussion on GATE previous year problems in our topic ordinary differential equation, and in that to higher order first degree. So as of now, in the case of higher order first degree, completely we have discussed about two types of differential equation, like homogeneous linear differential equations. Why we are calling linear? Because we are talking about first degree. And then we talked about non-homogeneous linear differential equations. So in the case of homogeneous linear differential equations, the general solution we called it as YC, complementary function, and in the case of non-homogeneous linear differential equations, the general solutions we called it as particular integral. And if we wish to write the complete solution, we can write it as y is equal to yc plus yp, because only in the case of non-homogeneous we have yp, so we have complete solution as y is equal to yc plus yp. And in the non-homogeneous only we had 5 cases first, and then if we doesn't have any case out of those 5, that capital X, like f of d into y is equal to capital X, right? So if that capital X is none out of those 5 cases we have discussed in the non-homogeneous linear differential equation. So we had discussion on method of variation of parameters. So that was the main discussion. And after that, if we have linear differential equation but the coefficients are not constant, because in the case of homogeneous or non-homogeneous higher order first degree, here we were talking about the differential equation with constant coefficients. But if the coefficients are not constant, but they are in terms of x, but we are having the equal power of x, like if it is dy by dx we have x in multiplication, if it is d2 by dx2 we have x square in multiplication. So we also call it as equi dimensional linear differential equations. And the name for that, why equidimensional? As I said, x into dy by dx or x square d2 by dx2 dx2. So the dimension is going to be same as that of differential. So we called them as Cauchy's Euler linear differential equation. So this is the complete discussion we did in the case of higher order first degree. So let us solve few problems related to these topics came in the GATE till now. So the first problem, it was asked in GATE 2011 in instrumentation engineering, and we are given with the second order linear differential equation of homogeneous type. So we have equation something like y double dash plus 2y dash plus y is equal to 0. And why I am calling it as homogeneous? Because it is nothing but d square plus 2d plus 1 into y is equal to 0. So it is in the form of f of d into y is equal to 0. So by substituting d by dx as capital D, we have something like f of d into y is equal to 0. And if it is of second order, it is quite possible that it is quite obvious that we are going to get two arbitrary constants c1 and c2 in the general solution. So that's why we are given with the two initial conditions, and it is being asked what is going to be the value of y at x is equal to 2. So whenever there is ask the value at exact point, we should have the exact solution. So for that only we are given with the initial conditions. So let us solve this particular expression first. So we have auxiliary equation as f of d is equal to 0. So this is nothing but d square plus 2d plus 1 is equal to 0. And if we try to get the root of it, we are going to get something like d plus 1 whole square is equal to 0, because a plus b whole square is nothing but a square plus b square plus 2ab. So we have roots as d is equal to minus 1 and minus 1. So we have two roots a and a, but if they are repeated, so we are going to get terms like c1 plus c2x and e power ax, right? In the case of real root, we are going to get exponential term, but if they are repeated, so we are going to write something like c1 plus c2x. So the general solution, the complementary function, it is going to come out as c1 plus c2x and e power minus x. And now we have to calculate c1 and c2. So we have first condition at x equal to 0, y is equal to 1. So 1 is equal to c1 plus 0 into e power minus 0, and e power 0, sorry, minus 0 is nothing but 1 upon e power 0, and 1 upon e power 0 is nothing but 1. So 1 upon 1 is 1. So either it is e power 0 or e power minus 0, it is always 1 only. So from here we have c1 is equal to 1. and in the second condition at x equal to 1 we have y is equal to 0, so y is equal to 0 and x equal to 1 e power minus 1. So we have 1 plus c2 is equal to 0, because if we divide anything in 0 we are going to get 0 only. So from here we have c2 is equal to minus 1. So we have our exact solution, because this was our general solution, but if we have the initial conditions we have the exact solution, the complementary function as 1 plus c2x. c2 is nothing but minus 1, so 1 minus x into e power minus x. And now it is being asked that what is going to be the value of y at x is equal to 2. So just put simply 2, 1 minus 2 e power minus 2. So 1 minus 2 is nothing but minus 1, and e power minus 2 is nothing but e square. So we are going to get something like minus 1 by e square. So I think this is going to be the option number C. Minus term was missing there, so we have option C as minus 1 upon e square. So this is going to be the answer for our this particular problem. And now let us solve problem number 2. So problem number 2 is nothing but it is given directly in terms of f of d itself. So d square minus 2d plus 4 into y is equal to 0. So again it is homogeneous linear differential equation of second order. So f of d into y is equal to 0. So auxiliary equation f of d is equal to d square minus 2d plus 4 is equal to 0. If we try to calculate the root, this is nothing but d square and minus, this is minus 4d plus 4. So this is nothing but d minus 2 whole square is equal to 0, because a minus b whole square is nothing but a square t square plus b square is 4 minus 2a is nothing but minus 4d. So we have again the real roots and in the repeated nature. So we are going to write the general solution as yc is equal to c1 plus c2x and e power ax, because if we have root a and a we are going to get the exponential terms like e power x, but if they are repeated again we are going to get c1 plus c2x, so e power 2x. So this is going to be the general solution, and only general solution is being asked. So this is going to be present in the one of the options, c1 plus c2x e power 2x. So and it was asked in GATE 2005 in instrumentation paper. So now the third problem, it is asked in the GATE 2018 civil engineering, and it is of second order again and homogeneous. So I'll write directly d square plus 2d plus 1 into y is equal to 0. So f of d into y is equal to 0. So homogeneous one, and we have again two conditions, because we have second order differential equation. So we are going to get two arbitrary constants c1 and c2. So let us solve that, and again this is of kind of format number 1 only. We are asked with the value at x equal to 1 what is going to be the value of y. So first let us write the auxiliary equation. F of d is equal to d square plus 2d plus 1 is equal to 0. So this is nothing but d plus 1 whole square is equal to 0. So we have roots as minus 1 and minus 1 again. So I think this is something like that only. Exactly the equation is same, only initial conditions they have changed. So we have the general solution, y is equal to yc is equal to c1 plus c2x into e power minus x. So the first condition says at x equal to 0 we have y is equal to 1. So 1 is equal to c1 e power minus x, because this is 0, and e power minus 0. So from here c1 is equal to 1. I think till here the problem is same as that of problem in GATE 2011 in instrumentation. And now we have the second condition, dy by dx at x equal to 0 we have minus 1. So first we have to differentiate this. Dy by dx is equal to let us write something like c1 e power minus x plus c2x e power minus x. So differentiation of e power minus x is nothing but minus e power minus x, c1 e power minus x, plus, and differentiation of c2 is nothing but constant, and differentiation of x e power minus x will have to make use of addition property. So e power minus x same, and differentiation of x is 1, and now x is same, differentiation of e power minus x is minus x e power x minus e power minus x. So at x equal to 0 the dy by dx is equal to minus 1. So x equal to 0, this is going to be 0 plus c2, and x equal to 0, this is 0, and this is also 0. So we have term like e power 0 is nothing but 1, sorry. So we have minus 1 plus c1 is equal to c2. So from here c2 is equal to C1 is nothing but 1, so 1 minus 1 is 0, so C2 is 0. So we are going to get the YC as C1 is 1 and C2 is 0, so e power minus x. And now it is asked what is going to be the value of y at x equal to 1. So y is nothing but e power minus 1 by e, so answer will be 0.37, because 1 by e is something 0.3679, something like that, but it is being asked we have to write the answer up to 2 decimals. So if it is like 0.3679, so the up to 2 decimal we wish to write, and if the third decimal is greater than 5, we have to round off the second decimal and increase the 6 by 1. So we'll have to write the value as answer as 0.37. So this was the problem asked in GATE 2018 in civil engineering, and it was quite similar that of to that of GATE 2011 instrumentation problem. Only one condition they have changed. Instead of y of 1 is equal to 0, they have given dy by dx of 0 is equal to minus 1, and the value asked was at different point. And now the fourth problem we have from GATE 2017, again from civil engineering, and we wish to write the particular solution. So in the case of homogeneous we have only complementary function, whereas in the case of non-homogeneous we can have both complementary function as well as particular solution. So the completely we have complete solution, but it is interested only in the particular solution only. So we have to write f of d. So this is nothing but d square minus 4d plus 3 into y is equal to 2t minus 3t square. So this is nothing but a third case, x power m. So we have terms like t instead of x. So this is third case and it is of polynomial type. So how we have to do that? We have to take f of d inverse. So the particular solution or particular integral is going to be 2t minus 3t square upon d square minus 4d plus 3, and we have to make use of binomial expansion, right? So we have to make this term something like 1 plus, so 2t minus 3t square divided by 3, I will take common, this will become 1 plus d square minus 4d divided by 3, right? If I take 3 common, this will be 1 and this will be divided by 3. So now we have yp is equal to 1 by 3 and 1 plus d square minus 4d by 3 whole inverse, and our polynomial is nothing but 2t minus 3t square. What we have to do? We have to make use of binomial expansion and apply all the differentiation up to possible 1 on this particular polynomial. So we have to make use of binomial expansion. 1 plus x whole inverse is nothing but 1 minus x plus 2x square minus 3x cube plus something like that. So we have to make use of initial terms only. So 1 minus x, this complete term is x, so 1 minus x d square minus 4d by 3 plus x square d square minus 4d plus 3 whole square, and all the terms we can neglect and we have 2t minus 3t square present over there. So now we have to up to which term we have to write, because this is nothing but polynomial of second order, so we are going to get differentiation up to 2, because higher order differentiations are going to be 0 only. So we should take term first from up to second differential. So this is nothing but 1 minus d2 square by 3 plus 4d by 3 and a square, sorry, first we will take 1 by 9 out, 3 square is 9, and d square minus 4d whole square is nothing but d power 4 and plus 4d whole square, so 16d square and minus 2ab, so that is going to be third order. So let's neglect that and write 2t minus 3t square, right? If we expand this, we are going to get the terms like d power 4 and d square and d cube. So only up to d square we have to take, so I have taken that. So now differentiate this particular term inside that. So 1 by 3 and we have 2t minus 3t square minus 1 by 3, differentiation 2 times. So one time differentiation is nothing but 2 minus 60 and second time differentiation is minus 6. So second time differentiation is minus 6 and plus 4 by 3. One time differentiation is 2 minus 60 plus 16 by 9, and 2 times differentiation is minus 6. And just simplify that, we are going to get the particular solution of our problem. So we have yp is equal to 1 by 3, let's keep it outside only, 2t minus 3t square and minus minus plus 2 and 4 by 3 into 2 is nothing but 8 by 3. And now we have minus 3 2s are 6, so minus 80. And minus 3 2s are 6, 3 3s are 9. So 32 by 3. Right, okay. So we have yp is equal to 1 by 3, and let's write all t terms together. 2t minus 8t is nothing but minus 60 minus 3t square. So this and this are over, this also over. So 2 plus 8 by 3 minus 32 by 3. So first let us solve by 3. 2 plus 8 minus 32. So nothing but 24 by 3. 24 and 8 is 32. Okay, so minus 32 by 3 and 3 8s are 24. So 2 minus 8 is nothing but minus 6. And now divide by 3. So minus t square term shall we write first? Okay, so minus t square minus 2t and minus 2. So this is going to be our answer. So only particular integral is being asked, so we have to write only particular integral. So if it is also asked like complete solution, in that case first we'll have to write something like f of d into y is equal to 0, then calculate complementary function, and then calculate this particular integral, and then the complete solution. So that is going to be lengthier one, so that's why he has done only particular solution. And now let us have the look of last problem, which is nothing but x2 d2y by dx2 minus 7x dy by dx plus 16y is equal to 0, and only the general solution is being asked, and that is nothing but our last topic of discussion, Cauchy-Euler differential equation. So what I said, we are going to have the equi-dimensional terms. So the if it is dy by dx we have x, and if it is d2y by dx2 we have x square. So this is nothing but Cauchy-Euler differential equation. And how to solve that? In that case we have to keep in mind the substitution. E power x is nothing but z, and so x is equal to log z. So this we had to keep in mind, and also d by y dx, right? So x dy by dx we have to put as capital D y, and x2 d2y by dx2 we had to put it as d into d minus 1 y. So this was the substitution we had to keep in mind in the case of Cauchy-Euler differential equation. So let's substitute that. D2 y minus d into d minus 1 y minus 7d y plus 16y is equal to 0, and this is going to be something like d square minus d minus 7d plus 16 into y is equal to 0. So d square minus 8d plus 16 is equal to into y is equal to 0. So this is going to be our auxiliary equation. F of d is equal to d square minus 8d plus 16 is equal to 0. And also we have to keep in our mind that capital D is nothing but d by dz, it is not d by dx. So the solution we are going to get in terms of e power z. Okay, so this was x is equal to e power z, and z is equal to log x. This was our substitution. So solve for the roots of it. So alpha plus beta is equal to 8, and alpha into beta is equal to 16 by comparing it with our standard quadratic equation whose roots are alpha and beta. So x square minus alpha plus beta x plus alpha beta is equal to 0. This is our standard quadratic equation with root alpha and beta. So alpha plus beta is equal to 8, and alpha into beta is equal to 16. So alpha is equal to beta is equal to 4, I guess. So this is nothing but d minus 4 whole square is equal to 0. So we have the roots as d is equal to 4 and 4. So again real and repeated roots. So we are going to get the general solution as c1 plus c2. Instead of x we have to write z. c1 plus c2z e power 4z. And now put back z is equal to log x and e power z is equal to x, right? So e power z is x, so e power 4z is nothing but x power 4. So y is equal to c1 plus c2 log x, and e power 4z is nothing but x power 4. So this is going to be a general solution of Cauchy-Euler linear differential equation. So that's all for this particular session, and in the upcoming session we will try to solve more problems from different branches. So if you have any doubt, you are free to ask in the comment section. Thank you.